Okay, so in the previous tutorial we have seen how we can manually add this cycle animation, but now let's see how we can dynamically determine a specific animation based on the cardinal direction. Um, so in order to do that, first we need to calculate the directions, and we have to determine what is the respective cardinal direction that is being pointed out. Okay, so first, in order to do that, uh, let's create an enumeration to generalize our cardinal directions. Okay, so I'll go to data. Under enums, I'll create a new folder called locomotion, and there let's create a new enumeration called e underscore cardinal direction. So E stand for prefix for enumeration based on the standard naming convention followed by the Unreal Engine. Okay, sorry, that was from my reference, but yeah, this is our end enumeration. So here, let's add 4 enumerated values called forward, backward, left, and right. Yeah, these are the 4 cardinal directions that we are focusing on. And now yeah, now maybe we can implement a function to determine a specific cardinal direction. Yeah. So let's go to the AVP locomotion, and I'll create a new function called select cardinal direction from angle, and let's make it a pure function because we are not going to modify anything inside of this function. Instead, we simply make a set of calculations to determine the cardinal direction, right? So make sure whenever your function is not involving any sort of a mutation, you can make it as a pure function. Okay, so we need 4 variables to determine this cardinal direction. Obviously, we need to feed the angle of the pointed direction, and maybe it involves set of dead zone parameters as well, which means like in a certain dead zone we don't need to recalculate the cardinal direction. Instead of that, we can pass the previously calculated value, right? So this will be for the safe side of the animation tweaking, plus it will reduce the performance impact as well. Okay, and then we have to pass the current cardinal direction, because only if a specific cardinal direction change happens, we have to return the value or recalculate it and store it again. So we have to pass the current cardinal direction, which is the say enumerated value, and then maybe we can use another variable to override the current direction as well. So I'll pass a boolean variable called use current direction. It is a boolean value, and those are the inputs, and as the output we are simply returning the direction, cardinal direction. Okay, so I'll keep the return here and break the pin just for the reference. And now yeah, now we can do the calculation. So first we don't need the sine of this angle. All we care about the magnitude of this angle. So maybe we can take the absolute value and store it as a local variable. So I'll name this as absolute angle, like this. And then maybe we can reference this dead zone and store forward and backward dead zone values. Do that. Let's get the dead zone variable, and I'll make a local variable called forward dead zone. And maybe we can use the same variable for the backward dead zone. Okay. And then you need to calculate these dead zone values. So I'll add a sequence, and here I have to first check whether we are going to use current direction or not. So if you are going to use the current direction, you may have to update these dead zone values. When I do that, we get the current direction enumeration value, and we can make a switch. And since our calculation is only involving with forward and backward cardinal directions, we can use these two pins only instead of this left and right. So let's get the forward dead zone and multiply it by 2 and set this thing. Right? So basically what this do is, if you are moving, it will double the forward dead zone value. And similarly, for the backward as well, we have to make it double. Right? So simply what we are doing here is, if we start to moving and we are moving in forward and backward direction, we are making our dead zone bigger so that player will remain that specific forward or backward animation in a quite long time, if that specific movement direction is forward to that specific direction. Only if like left or right, or maybe even A or D keyboard inputs has been given, the player will be able to get out of these dead zone values, and then the left or right related cardinal direction related animations will get played. Right? Otherwise, these two variables will be used to keep playing the forward or backward cardinal direction specific animations. Right? Okay. Maybe we can make a comment here. Keep playing forward, backward animations, and make it harder to leave those states, right? So for a minor change of the inputs, these states won't be get changed, right? Okay, and then as the next sequence, we can calculate the cardinal directions. So how we can determine whether we are moving to a forward direction? So first we have to get the absolute angle, and we have to check whether it's less than or equal compared to 45 angle, and since we have the dead zone, we have to add the forward dead zone as well. So if this thing is passed, so I can add a branch, and I can add a return value here. So if this thing get passed, that's the forward direction that we are pointing out. Maybe we can make comment here called forward, and then how we can determine whether we are moving in backward direction or not. Simply the same calculation, but the condition will be different, which is we have to check whether the absolute angle is greater than or equal to 135 degree angle added the forward dead zone value. Okay, and if this thing is true, then that's the backward direction. Okay, and then we have to use the angle. Make sure to use angle value, not the absolute angle, because we have to consider the magnitude when you're determining whether we are moving to left or right. So make sure to use left angle parameter, and we can simply check whether it is greater than 0 or not. And if it is greater than 0, which means a positive value, then we are moving to the right direction. Which is right. And if all the conditions are failing, then we are moving to the left direction. Okay. Now we have to use this function inside our velocity calculation function. So let's first go to the update velocity data. There, after this local velocity 2D calculation, maybe we can use this function. And now we have to feed 4 of these values. And for the dead zone, actually we can hard code it because this is just a configurable value. So maybe let's promote it to a variable and call this as cardinal direction dead zone, and I'll add to the settings category, and maybe we can provide a value like 10, right? So the offset value or the dead zone value will be 10, right? And then for the use current direction thing, maybe we can use whether we are moving or not. So only if we are moving, we do the calculation, otherwise we can remain in the current direction only, right? And then Yeah, and then we have to feed the current direction. So in order to feed the current direction, first we should have the previous direction stored in a variable. So I'll promote this to a variable called maybe local velocity direction, and now we have that local velocity direction variable for the previous frame, and we can attach it to this current direction frame, current direction parameter. Okay, yeah, maybe I have to make this cardinal direction calculation related function thread safe as well, otherwise it will fail. Yeah, so if I make it thread safe, now that error has been gone. And yeah, so 3 of the parameters are done, and we have to resolve local this angle calculation as well. Yeah, so let's see how we can do that. Yeah, so now do that. First, I think do we have the direction thing? Yeah, we have the world rotation. So maybe we can use this world rotation and world velocity 2D to calculate the direction. So let's use these two variables, and let's use this calculate direction function, and let's plug the world rotation as the base rotation. We can promote this to a variable called maybe local velocity direction angle. Write it to here and here. And maybe we can move all of these to the world velocity category. Okay, now we have local velocity direction angle that has been calculated using the velocity and the rotation, and we can plug that to here as the first parameter. Yeah, so ideally this should return the local velocity direction properly. So now test that thing, can log this enumerated value, compile, okay, the log. Yeah, so if I move forward, it will say I'm moving forward. If I go to the backward, you can quickly see the changes has been happened, but it's not quite accurate. I mean it's accurate, but it's quite hard to see because our character is rotating or orienting its movement to the direction, rotating its direction for the movement direction. So in order to test this thing, maybe we can enable this use control rotation U, and maybe yeah. Now I think character is not orienting to the direction. So you can see if I move forward, the cardinal direction is forward, and if I move backward, the cardinal direction is backward. If I move left, it is left, and if I move right, it's right. And if I moved diagonally, you can see due to that dead zone configurations, it is pointing to the forward direction. And if I moved in the other way, it's also forward, and still it's showing properly. Yeah, so I think cardinal direction values are okay for now. Yeah, maybe now what we have to do is play different animation based on those cardinal values. Okay, so now do that, we can go to the BP locomotion, and I'll keep this log till until we finished the animation stuff. So I'll keep this log, and maybe I can move this function to another category called maybe let's say helper functions, and then can go to the locomotion dynamic graph, and we are at the cycle state. So instead of hard coding these values, I'll get rid of this thing and I'll add a sequence layer and plug this to here. And in this sequence player, same we did in the idle animation stuff, make sure to make that sequence dynamic. And so since this is a cycle animation, we have to focus on update function. So let's create a new binding called maybe update cycle anim layer, and maybe we can move this function to anim node functions, where we keep all the anim node specific functions related stuff. Okay, now what we can do is we can set sequence with initial blending, not for the sequence evaluator but for the sequence player. So make sure to select this one. So we have the sequence player here, and let's convert this to a sequence player like this, and the blend time would be fine, and this sequence is the one we have to figure out, and we can simply return it here. Okay, now based on the cardinal direction, which is this one, local velocity direction, we can make a select like this and add this to sequence, and it exposes 4 selectable values for us. And just for the testing, let's use these unarmed values. So maybe for the forward one, I will use this forward animation. Compile. Forward animation. And for the backward, I can use backward animation. For the left, this one. For the right, this one. Compile, save, and let's play this thing. Now you can see when we are moving forward, it plays the forward animation, and we are moving backward, it's the backward animation, and for the left, it's the left animation, and for the right, is the right animation. Okay. So animations are swapping correctly, but as you can see, whenever we move diagonally, it's not quite visually appealing, right? So we can maybe update those stuff later on, but for now this would be fine. Yeah, now we have to figure out how to get these values from the data table instead of hard coding, right? So for that, I think we may need to improve our data structures a little bit. So if I go to the structs under the locomotion, we have is anim set, and currently it have this idle stuffs only. And for the sprinting related data, no, not the sprinting, actually jog related data, I think we can create a new struct, right? So maybe I'll create a new folder called movement, and there let's create a new structure called is anim jog. And here maybe we can add what are the cycle cardinal direction specific animations and what are the respective configurations. So these configurations can be generally applied for any sort of animation sequence. Therefore, I think it's better to create a new structure for those configurations. So let's create a new blueprint structure called sanim config, and I'll add two variables called max walk speed, right? Because most of the time, based on the animation, we have to define what is the max walk speed that should apply for the character or the pawn. So it's better to have a configuration like this. And also, what is the max acceleration? Max acceleration. And maybe we can make it as a float value, and by default I will add 500 and 1500 as the acceleration. Yeah, but these configurations will be applied in maybe like sprinting and other related stuff in the later episode probably, but just for the safe side, I just created this config structure as well. And we need another structure called anim cardinal, and usually we need 4 different animation sequence just to be stored. So first one should be forward, and it should be an anim sequence object reference. Similarly, we need 3 of these more for the backward, left, and right. Okay. And then we can go back to the sanim jog structure, and we can create a variable for cycle cardinals, and we can use that sanim cardinal data structure. And for the configurations, I'll make another parameter called config, and I'll add that sanim config data structure. For the default value now, cycle cardinals are empty, and we have these default configurations. Okay, now we can add this thing to the sanim set. So currently we have these two variables or these two fields. So let's add a new field called jog. Sorry. And for the jog, we can add that sanim jog data structure, and now we can populate those stuff here. Okay, and then we can go to the data table and let's add those animations to here. So first I will make the changes to the unarmed animation and test those things out, and if everything was properly, we can populate this pistol and rifle anim sets as well. Okay, so here first we need unarmed jog, forward and backward and left, then right. Yeah, those are the 4 values and the respective configurations. And now let's go back to the ABP locomotion and let's go to that initialization function, and initialization we go to this locomotion event, and there we set this animation data. Okay, so let's go to this set animation data function, which is a initialization function, and there let's add a new sequence for these cardinal directions calculations. So we have this local movement struct, and I'll break it, and here now we have the field called jog. So maybe we can break that thing as well. And for the cycle cardinals, we can create a new global variable called cycle cardinals. Okay, so I'll collapse these nodes and mark it as cardinals. Okay, so now we have a reference for the cardinal variables or cardinal anim sequences that has been stored at this dt anim set data table. Plus, for the organization purposes, I will add this to the anim sequences category. Okay, now let's go back to the anim graph, locomotion, cycle, and this update cycle anim layer function or anim node function. And instead of hard coding these values, what we can do is we can take this cycle cardinals variable, and I'll get it, and let's split it and attach the corresponding stuffs. Okay, now the pins has been attached properly, and yeah, let's test the thing. Yep, it's playing properly. So now we haven't hard coded anything, we are simply taking the values from the data table. Yeah, so let's populate other stuffs as well. And for the pistol, maybe we can use the unarmed, but pistol thing. Pistol forward, backward, left, and right. Okay, so let's go to the BP player base and select this PPC locomotion system, and inside the setup, let's set the anim set to pistol. Let's play the thing. Yeah, you can see it's playing a pistol related forward, backward, left and right animations. Okay, and then go to the rifle and plug those values. So rifle forward, backward, left, and right, and play base. Let's switch the anim set for rifle, compile, save, it again. Now you can see it has this rifle related animations. Okay, and the cardinal directions are working properly. But here, as you can see, this need to be further improved. The first thing I notice is like the walking speeds are not quite matching with the animation. So that's why actually we have created that config structure. There we can tweak those values quite handy way. But let's see how we can do that in the next tutorial. Plus, you can see the diagonal movements are not working. So maybe we have to do some orientation warping for our animations to to resolve that thing. Yeah. So those are the possible improvements that we can do for the cycle animations, and let's see how we can do that in a upcoming session. So yeah, thank you. See you there.